Thank you very much, Olivia. All right, so infrastructure platform engineering. Um, right, that was the topic for tonight. Okay, so let's see. And this is the agenda for it. So first, let's get on the same page. I try to keep the marketing content in my webinars down to the smallest amount possible because I personally, as a platform architect, identify as the techie. Yeah, but of course, you cannot be spared of all the slides. So that's the part where this happens. Um, then we take a sneak peek into what service delivery versus cloud providing actually means. Dip into a possibly controversial slogan. Silos are awesome. Um, that was actually uttered during the last platform con, and let's see what that means for infrastructure platform engineering. Yeah, and then in the end, we actually come around to a demo part. So let's dive right in. So I'm actually working for Humanitec, and Humanitec is sitting here in the products part of Platco Group. So Platco Group is the one partner that you need for all your things platform engineering, and you can read faster than I can read the rest. So let's zip right ahead. I'm just sitting down here in the products part. So, and just so we have a common frame of reference, let's dive into the problem surface where we normally dabble in. So, pain to impact through platform engineering. So, where are we? What I hear a lot from people that I interact with in general when it comes to platform engineering is always the same pain points. And they are coming from the developers. They are missing self-service. The cognitive load is high because they can't just order something via self-service. They need to understand what they actually want to order. Yeah, not just say, hey, I want a database, but actually understand how to configure that database to the max. And then ask for exactly that configuration. Asking for it means waiting on it, and obviously that's slow. And at the other side of this equation are the infra and operations people, right? They are ticket opsing their day, so to speak, because they receive all of these asks and they somehow need to turn these configuration requests into actual instances of things, right? Most of the time they get insecure configurations. Obviously, that's not highly standardized, it's lowly standardized. So they need to do manual reviews, and all of that takes time. Cost is spiraling out of proportion. Nobody's happy. So, from our perspective, platform engineering is the remedy to that situation. And the main value drivers are actually automation and to get these things automated. The developers have their champions in the platform team, so to speak, which are the developer experience or developer excellence platform engineers. And why is their weapon of choice automation? Well, simply because missing self-service can only be remedied if something is completely automated, right? If there is a manual step somewhere in between, it's not really automated. It's still ticket ops. Well, that's great. And if you have automated all of that and developers can just push a button to get their instance of something, um, and they can still have a lot of choices what something actually means, well, then the people at the receiving end here, the in front ops people, are still not happy, right? Because they need to care for all of those instances on day two. Yeah. And to actually remedy this situation, they have their champions as well, the so-called infrastructure platform engineers. And their main weapon of choice is standardization. And that is very important because only if those things which are automatically created are also standardized sufficiently, then you can employ fleet management tactics to care with the vast amount of things that developers actually create. And that leads to time to market and cost going down, innovation going up, and managers being happily impaled on top of this pyramid. I haven't understood that part yet, but somebody from marketing is going to explain it to me one day. Yeah, so this is the field that we are actually playing in, and I hope that those pain points resonate with you. because we are going to look a little bit deeper into this personality here, the infrastructure platform engineer, and how they can actually make it happen and how they can be integrated into the platform team, that all of this proposal to reach this state up here comes true. Right. So what does that mean for infrastructure and operations people actually? What is their main problem? If you think about infrastructure and operations, those are literally not the people who are tasked in your company, probably even you, to build a platform or which are part of the platform team yet. They are rather the people who are responsible for providing a certain service. Let's say you have a department in your company and their job is to provide database as a service, like Postgres as a service. Yeah. So their scope is very fenced in. It's narrow. They completely understand what their scope is, and they provide a rock solid and great service. Well, is it so? The question is, from the outside, the perception, is it like that? Let's take a look. Most of the time, oops, no, it actually comes up all at once. All right, cool. So we're looking at service delivery versus cloud providing. Do you know those suspects? Yeah, let's talk about the main problem here that the I&O people have, because they are rather sitting on this side. Yeah, the interface is the problem. The problem isn't building that robust service. Most of the time, even providing a sensible API to CRUD these things, which is beyond the Jira screen that you see here and allows developers to actually request an instance via an API, is not a problem. But the interface around it. Yeah, cloud providers over here are notoriously good in providing and building good interfaces. Yeah, it's part of their core business model and scales very well with the number of customers. The more you invest into a great API, a great UI, a great portal, a great whatever builds the surface of your offering, it will pay back with customer by customer who gets to be a customer or who stays a customer. So usually it's not part of the business model of a database as a service department to provide a great cross-cutting experience around their database. Yeah. So that is a problem. Yeah, because developers, they love this here, obviously. Yeah. And also, they do not have the luxury of hyperscalers that they can follow the split path model. If you're on this side of the equation, what you can simply do is you can say, you want something really custom? Sure, but you have to care for it on your own. Just go the way of IaaS, so infrastructure as a service. Get yourself some compute, networking, and storage and build out the database of your dreams. You want something managed? That's the other side of the path, right? Sure, but you have to stay inside of the confines of what our managed service is actually offering you in changeability. Yeah? That's effectively limiting the amount of invariance you have to care for with your operations team. And because they offer the other side as well, people do not feel intimidated by stepping into as a service. Yeah, getting less options because they know they could break out at any point in time. Over here, that's not really an option. Yeah, so how does that work for I&O? How can they actually confidently go up against this? That's the main question. So, and that actually leads more often than not to the situation that when you're building out a platform, so you're coming onto the screen now, being tasked with building a platform, that you build a platform that looks like this. So this is one of our reference architectures that we provide. They are open source. You can find them not only in this wonderful slideware form, you can actually find them on GitHub. They are completely terraformed. Go ahead and take one of them for a spin. Push, insert a few variables, bring your own cloud account, push a button, and you'll be there in no time. Get something up and running. Yeah. So, but what is the thing with this? right? I can see a developer control pane, so they have the interaction surface up here cared for. Developers can happily play around there. Integration and delivery is actually pointing at the cloud provider of your choice, which is here AWS in this case. Yeah, and we also have cross-cutting concerns like monitoring and logging and security already sorted into the picture, and everybody's happy, right? No, of course not. The INO people, they are not happy because where is their database as a service? Yeah, you were tasked to build out a platform, and developers told you, yes, of course, we want the cloud provider because they are used to all of the cozy little commodity that the cloud provider and its interface is actually giving them. And because of that, your platform looks like this. Yeah. While if you think about it from your company's perspective, it should probably look a little bit more like this, which doesn't look so different, right? It is actually a reference architecture as well, but this one is for hybrid cloud. Hybrid cloud in this case means we still have the developer control plane, which allows for the same interaction surface. We still have the integration and delivery plane, which does all of the delivery towards the resource planes. But now we have more than one. And one is still your favorite cloud provider, but the other one is actually your data center. And inside of there, you probably, in my example, would here in the data column would have your favorite DB as a service department with their service. And if you think about it like this, then all out of a sudden, all of the customers are sitting on the table, right? The customers of your platform, not only the developers, but also the INO people who actually want to have their service on top of the platform as well. And because the observability and the security, they do not stop here in the cloud provider, they reach over and care also for the other resource plane. Well, all out of a sudden, this DB as a service gets as composable as the services over here from the cloud provider. Right? Because spinning it up through your platform will integrate it with the observability, like the cloud provider service. So the metrics and all of the logs and all of the connections of the applications, they will happen in the same way. All out of a sudden, it is not a sensible go-to for the developer anymore to just say cloud provider because that's much more convenient. Because the platform now is the abstraction layer and the interface, which allows for the same access towards what the INO people are actually building and delivering. And this is the mainstay of infrastructure platform engineering. Yeah, infrastructure platform engineering is, so to speak, the lowest level of the layer cake, where you have your services, which are provided possibly on top of your own data center or of your virtual data center, whatever that is or means, right? But they are managed and cared for by your own company. And they are now on equal footing with another layer, which is, or some items on the sidelines of that, which are provided by the cloud provider, because there is a layer on top, which is the internal developer platform and which is equalizing the access. All right. So let's dive into this one a little bit more, right? Silos are awesome. It's a little bit controversial to say that in 2024, but let's look at it like this. If you're traveling, right, how would you like your taxi service? Cab arrives, driver leaves, you load your luggage, drive the cab to where you want to go, use the self-service payment facility, unload your luggage, and leave exhausted. I bet you would like to be a consumer of that service with clear boundaries. So cab arrives, you get your luggage loaded by the driver, enter, communicate the address to where you want to be driven, enjoy the ride, get your luggage unloaded, pay smiling, and leave happy. Right? That's a service with a clear boundary. And actually, that's a silo. The definition of a silo with a clear interface and a clear boundary. Yeah. you don't want to break into that silo and take over being the cab driver. Yeah, that would not actually be great. And it works incidentally in the same way for any other kind of service. Like this database as a service, for example. Yeah, you would rather like to get your database and then not need to care for it anymore, because you not only get the database, but you get a connection string delivered as well to your doorstep, and all of the other tasks of keeping it alive, backing it up, restoring it if needed, distributing it around the globe, making it highly available, caring for a secure configuration. All of that is happening inside of the silo, which is what we usually call a managed service. Yeah, you can find that pattern in the real world a ton of times. Yeah, domain-driven design, bounded context. That's the thing. Service communication, sender-receiver contracts, or an API. That's the thing. Team topologies, building and alignment of task-focused teams. Once again, developers and infrastructure. Well, let's talk about that one. Let's see how we can make that happen more elegantly. Right. So, SCORE. This is an abstract format for developer self-service. And it is a workload specification which is under control now of the Cloud Native Computing Foundation. And what you can see here is a SCORE file that allows the developer to actually do an abstract request against a platform. So I, as the developer of the product service up here, am actually asking my platform to supply me with a little bit of infrastructure. A Postgres database, creatively named DB, an S3 compatible blob storage named Bucket, and a DNS record, because who likes writing IP addresses? That's a little bit of plumbing happening as well with the routing here. So I can specify the entry point into my product service. And then I'm telling the platform, well, if you build out this database, please be so nice and conveniently drop those variables here into my connection string. So the username of the resource called DB, drop it here. The password at the host, you get the idea, right? That continues off screen. And that forms a Postgres connection string. Yeah, and because of that, because all of that is happening in one step, the infrastructure is being created and being stitched up with the application. The application can now read that from this environment variable when it starts and connect to the database. That means that now this product service is atomically deployable with the infrastructure that it needs to prosper, so to speak, in the runtime environment. That's great, because now I'm losing all of that specific need for knowledge and configuration for the developer. I can simply care about the only thing that interests me, how to connect that database to my application. But if nobody fills in the details for what this here actually means, then nothing happens, right? So who fills in those details? And the simple answer is the platform engineers, when they build out the configuration for a platform. And specifically in this case, for a platform orchestrator. And that orchestrator has the task to actually connect the dots between what the developer has been asking for, what the platform engineer has been configuring, how it should happen, and the actual execution and orchestration of different parts of your platform, so that they, in a nice choreography, care for the things to happen. Right, so how to configure this orchestrator thingamadooda? Well, simply spoken, there are different ways. One of them is, once again, a YAML-based format, because today everything is YAML. Yet another. All right, so here we go. We're reasoning about a resource of type Redis, and that's actually being created by a Terraform module that's lying here under revision control, and this should be applied when the environment is staging. So now we have a context. Something is being deployed to staging. Okay. And then we call this Terraform module to create a Redis cache. So how is it coming together? Let's say that the orchestrator creates a resource graph from the SCORE file that the developer provides. and the resource definitions. So platform engineers have been busy as a bee to fill the configuration repository here with resource definitions. And some of them might actually create cloud provider based stuff, and some of them might actually create stuff using APIs or interfaces or abstractions that the I&O people provide for their services. That leads to the fact that now if a developer comes around with a score file asking for a Postgres database in an S3 bucket, the orchestrator, when being triggered by CI with the score file, knows about the context because CI was so as nice to pass this along and can look up the right configuration from here, can put those resource definitions inside of the nodes of the graph, so to speak, yeah, and create this graph. And then this graph gets executed. Yeah, if you remember, something could possibly be summoned by Terraform. All right, then for this node of the graph, we can execute Terraform. So why use a graph in the first place? Simply spoken, you can use a little party trick to actually make this graph into a flat line. If it is a directed acyclic dependency graph, like the ones which are used by all kind of infrastructure management tools, then you can simply sort it in topological order and it gets a flat line while still observing all of the dependencies. And a flat line can be processed simply, like a pipeline. And because of that property, we can now execute this graph very simply and create all of the infrastructure. And because not only the infrastructure is part of this graph, but also the deployment, the application, we can simply inform the application or the application configuration with the data from the infrastructure that we created, and everything comes together nicely. Next iteration, developer decides we want a Redis cache. You get the idea. Go here, orchestrator creates a new graph, adds the new resource definition to the node missing. That graph gets executed, Redis cache gets created, and the connection string gets inserted into the configuration of the application. Everybody's happy. Okay, so if you want to delete this once again, it's the same way over. Get rid of it, remove it from the graph, execute it. We'll remove the Redis cache from the environment, and we are back to safety. So if you think about a platform that looks like this, that actually turns your IDP, your internal developer platform, into a self-service vending machine. And I've heard this term golden paths quite a lot, and I like to think of it like this. This is my mental model of a golden path. We have this vending machine here in the middle, and this vending machine is actually being cared for and provided by the platform engineers. But the boxes inside here, the products that you can order, they are actually provided by the infrastructure engineers. Yeah, by the I&O people, sometimes by the infrastructure teams from the cloud providers. Doesn't matter. Yeah, it's all one size inside of the vending machine. And the developers, well, they can simply, in a self-service fashion, order whatever they like. And that's definitely a golden path because now all of those boxes are accessible in the same way, they're usable in the same way, and it's highly convenient to use this machine for the customers. It's highly desired for the infrastructure people to stuff their boxes inside of it. Yeah? And it also makes for great fun for the platform engineers because they feel that they are providing something really useful to everybody. And this model makes a lot of sense for any kind of corporation. And once again, this is what infrastructure platform engineering is about, including those people here, giving them a seat at the table and giving them the means to actually get their product in a meaningful way to their customers and making it more desirable. All right. Having said all of that, I think I have now arrived here. And this is as close as I can get with AI to hammer time without infringing any kind of copyright, I think. So here we go. That's been a lot of slideware. Okay. And that I actually didn't want to do that. Stop. Slideshow. That's what I wanted to click. Ha! I wanted to move over here. Sorry for that. So what you see here is actually my tenant inside of the orchestrator that I have prepared for this demo. It's called funny code here, and it's completely empty, as you can see. There are no applications here, and the orchestrator is even trying to get me to connect my infrastructure so I can actually start deploying something. It's giving me a few options what I could do. But I want to do something else. I actually want to not use the 5-minute IDP because that is quite limited in its reach. I want to use something else, which is called the pocket IDP. And for that, I can show you where this is living. Yeah, so it's actually living up here under GitHub in the internal developer platform pocket IDP space. Don't worry, you will get all links and in a nice form later down the road. So you can actually, even if this is not hands-on right now, you can actually replay and do everything on your own, right? So as you can see, this thing here looks like it is building something, and it is. There's a Docker file here. And if I follow the README and I fulfill the prerequisites, then I come to the point where it says, okay, export a few things in your environment. And I have already done that because I'm using a tool called DENV to pre-populate my environment. If I reload this, you can see that I'm pre-populating here all of the things that are actually here. Yeah. And for the pre-built container, I can simply execute this here. But I have updated something, so I'm going to go for the non-pre-built container and use make run local, which is simply just building the container once again and then starting it. Yeah, and for you, actually this year, the pre-built container will work quite fine, and I will push the new release this evening. Okay, so now I'm inside of the Pocket IDP. And all I need to do to start getting something going is to execute the install script. So what that is going to do now is it's actually going to start a Kubernetes cluster. And let me get to my dashboard here because I'm not allowed to cheat, right? You can see things appearing here. So I am actually running the 5-minute IDP here. It already started a registry and the kindest node. So this is a kind cluster which is being started. And now it's executing a little bit of Terraform to deploy some things on top of the cluster and stitch all of that together with the orchestrator. Yeah, so that the thing stops telling me, hey, you can't do anything. Please connect your infrastructure, and gets to the point where it says, hey, we can play. Yeah. This would already be finished by now if we were using the 5-minute IDP. Because the premise of that is get your first sip of an internal developer platform quicker than a bowl of ramen. Yeah. This one here is providing more capabilities, so it's taking a little bit more of time. As you can see, I'm actually deploying Gitty here. And Gitty is basically a GitHub clone, which will allow me to execute more advanced golden paths. Speaking of the devil, if you are here and you have basically got the thing running, what you can do is you can go here to tutorials. Inside of tutorials, you will find CNPG and the golden path. And you can literally, because they are also step-by-step tutorials, yeah, as you can see, you can literally follow them along. Yeah, what we are going to do here is we're going to take a little bit of this CNPG tutorial. And as I said, I'm not allowed to cheat. So I'm simply going to follow this tutorial as well. All right. So as in my example, imagine that you have a department in your company that offers DB as a service. They have built an interface that allows you to order a new Postgres cluster and database by putting a custom resource onto a Kubernetes cluster. That's great. So they basically built an operator, and now you can simply put a custom resource onto the cluster, which will be turned into an actual Postgres database that your your INO people care for um, via this operator. Yeah, you now want to utilize this interface and integrate it into your platform to make it easy for developers to actually get DB as a service instances. Yeah. All right. So what we need to do is we need to install the CNPG, which is Cloud Native Postgres operator, to simulate this interface of your DB as a service department. I know that this is a little bit of a party trick as well, right? Because most DB as a service departments would not expose that kind of interface, but you get the idea, right? The interface doesn't really matter as long as it's a clear silo that your DB as a service department is, and they provide you with an interface. You just need to use that interface, yeah, whatever that means. And in this case, we're going to simulate it like this. So I'm simply going to copy this command. And here inside of my, no, I need another terminal because I don't want to run this inside of my Pocket IDP. I want to run this on top of my host. So I'm changing into the same directory. The env is going to do its trick, its magic trick. And the only thing that I now need to do is I need to, as you can see, I'm switching my kubectl context to a GCP cluster, and I don't want to work with the GCP cluster here. I want to work with my kind cluster. So all I need to do is kind, right? I want to kind export kube config. Thinking, oh, great. My terminal is trying to help me. I didn't want to ask AI. I want to execute this. No. Right. And that's going to complain because I don't have supplied the name, which is in this case, looking over here. Well, let's ask it for that. Kind, once again, kind get clusters. Yes, run the command, please. Don't have a terminal which is actually running AI in the background for demonstrations. That's what I get from this. Okay, kind get clusters. 5min IDP is the name. I wanted to run it. So you can actually see what the name is. Okay, great. So now my kubectl context is set to my 5-minute IDP cluster, which is my Pocket IDP cluster. And now I can do a kubectl get nodes. And that is definitely not a GCP cluster anymore. Great. Finally, oh, right. That is not what I wanted to execute. That is what I wanted to execute. So now I can actually execute this command, which is applying all of the custom resources and which will give me Cloud Native PG or a Cloud Native Postgres, this thing on the server side. All right, now I need to connect the interface to the orchestrator. So first of all, I need the custom resource of a cluster. Yeah, as you can see, I'm initializing that cluster with a database. It needs to have a secret. The secret obviously needs to have a username and a password. And we were talking about resource definitions before. I need to put all of that into this resource definition. Right? That's a giant thing. Awesome. And to make this all a little bit faster, if you don't want to edit and combine all of this on your own, there is actually the whole thing here. So you can copy that and go ahead and say, I'm just going to start an editor here. And I'm simply going to put that into a file. And the only thing I need to do is I need to go into my orchestrator and find out after refreshing, NVAS. So I need to replace UZZQ here with NVAS. All right. That should be good now. Almost. Cool. Going to save this. cnpg.yaml. Save this. And now the only thing that I need to do is I need to humctl apply this to the orchestrator in the same way I would actually apply a manifest to a Kubernetes cluster, just using the CLI that talks to the orchestrator. Right, done. That means that if I have an application now, I can simply order a Postgres. Let's take a look at the resource definitions. This is inside of the orchestrator. It shows all of the resource definitions that I have, right? And I just updated the one which is called 5min IDP NVAS Postgres. I can take a look at the configuration and I can see, now, at least now I can see, this is actually writing out manifests. Here is the secret. Here is the PG cluster as it is configured here in my YAML file. Yeah. And you can see there are also replacers inside of here. And that means whenever I'm going to order a database through this resource definition, those replacers are going to be replaced. And I'm going to get a discrete instance for my application. Right. And now the only thing I need to do is I need to deploy an application. And conveniently, the Pocket IDPs come in with the one demo script. Whoops. Yes, of course. I need to execute this one inside of the Pocket IDP. It's coming with the one demo script, which is conveniently going to deploy a demo application for me. And that is also going to attach a Postgres to it. Let's see if all of this is coming together. So we're going to deploy this environment. As you can see, it's already deploying. It's being deployed by me. So pipeline is running. You can see the pipeline here as well. It's provisioning things. And as soon as we have a clear idea of what has been provisioned, there's going to be a resource graph available. Yeah, so the thing you've seen as slideware is now going to appear here as well, and it's going to show exactly how my application architecture that I've been asking for in the score file is coming alive. Just needs a little bit of time. Here we go. All right. Yeah, I can see my workload. I can see that my workload has actually asking for this Postgres database and a few things. Runtime error. That's what you don't want to see on a demo. All right, we'll find out what it is any second. I see. It's possibly the Kubernetes problem that things start in an erroneous state and only get good as soon as they are actually perceived as up and running. Okay, so this is actually the URL where I should be able to pick up my deployed application. And currently it is not available because I'm missing the port. That should be 30443. Not a secure connection, but I trust it anyway. Here we go. As I said, the container just needed to come alive and the database did take a little bit longer to come alive. So let's zoom in and see if all of that did come together. So this is an application talking to PostgreSQL 16.2 database on my cluster RW deployed with Score. Well, that sounds right about correct. Now, the only thing that's left for us to do is to find out if the Postgres database was actually provided by our DB as a service department. And let's find out by doing a kubectl get on the namespaces. and doing a kubectl get all on the namespace 5min IDP and vas 5min local. And as you can see, there is my cluster one, my Postgres cluster. There is the 3 services. Yeah, and there is the no, not the replica set, but the 3 services. And if I go back to here, I can see that the outputs are those, yes. And here comes the name -rv. And the reason for that is that CNPG is actually creating those 3 services. Yeah, one of them is read, another one read only. Read something, and then it's read write. Yeah, so I'm asking for the read write service here to connect my database. So this seems like this thing here is in place, because if it would not be doing this, I would see a different signature for my Postgres database. All right, I know that this was just a very short demo of the case that I did spin up during the presentation, but I hope it was sufficient to interest you to actually spin up the Pocket IDP on your own and take a look at the golden paths and find out what is in stock. As I said, this thing is capable of doing a lot more. It comes pre-configured with a local Git environment, which also is able to run Gitty actions, which are like GitHub actions, so can run pipelines, can do all kind of things. It comes with a Backstage portal that allows you to trigger self-service actions. It comes with a lot of stuff that you can experiment with, and which are also detailed quite finely in the Golden Path tutorial, hopefully. All right, having said that, over here, and I'm at the end of my little demo session. I hope that was enjoyable, and I'm going to hand it back to Olivia here with Q and hopefully A. And if you've not joined the Platform Engineering Slack by now, just scan this QR code or click on one of those links. Yeah, click on them in the presentation, right? You need to type in this one or click on it later when you get the slides, right? And this one here leads right to the Pocket IDP. Questions and hopefully answers. Here we go.
Yes, thanks, Clemens. That was great. And I'm also learning a lot of things as well. So, guys, this is your chance to ask the questions. So please put them in the chat section or the Q&A section, and I will read them out for you. So we'll give it a minute for the questions.
Right, yeah, you need to read them out. I can't see them at all. I can't see the Q&A tool. Where is it?
Yes, I'll read.
Ah, here it is. I think.
Okay, we've got one. Etienne is asking, what are the testing frameworks or practices with the Humanitec Orchestrator? Because of the graph dependencies, there is an infinity of combinations to test.
Haha. You might think so, but in reality, we are always talking about clear boundaries, right? So if you put something on the graph, it's a single entity which has a clear boundary, which is abstracted in our way by a so-called resource type. And a resource type has clear inputs and outputs. So whatever you define with your resource definition, whatever you are doing behind that, it needs to conform to that interface of the resource type. Yeah, so that makes it able to be handled in the same way by the platform and also forms the contract towards the developer, right? Because how useful would the Postgres database, for example, be if you would not get all of the parameters out of the system to supply you with the connection string? Yeah. And having said that, the graph is very formalized. It is a structure that you can run tests on if you fancy. But it rather makes sense to actually see if what you're defining inside of your resource definitions is actually complying to the input and output specs. And if it does so once, it will do so every time again, right? If you're not creating interesting edge combinations which lead to the fact that an output that is needed is not being supplied. But that would directly lead to an error condition in the orchestrator and give you a nice error message to follow up on. Choose your favorite testing frameworks. Yeah, should all work.
Okay, that was one question. We're waiting for more.
Ooh.
Eve said, thank you very much for this introduction of IDP Humanitec score. I need to read the doc and test.
Sure. Developer.humanitec.com if you want to go there. Yeah. There's also some cool tutorials and a learning path there. If you want to master Humanitec specifically, then you can do that there for sure. If you want to have more general discussions, take a look at other orchestrators possibly, or just have more questions to follow up, which are just not yet crossing your mind, well, then just join platformengineering.org community and hit me up on the Slack there. My username there is @j. Just write to me. I usually am pretty extroverted. Right. And as Liv has already said, it's a great community. There is not a single day where we are not having some interesting discussions about platforming there. And it's also very welcoming. So just join and discuss all kinds of things with us.
Exactly. Yes. Well, everyone's been a little bit quiet. So, guys, is there any more questions that you might have? Don't be shy. Pop them into the Q&A section or the chat.
And if not, then there is only one thing left for me to say, and that is thank you for your time and staying with me, listening to my ramblings.
Okay, we've got one more, actually. Sorry.
Yes.
One more.
Yeah. One more thing. Right. Hey, no problem at all. Is the orchestrator able to execute any Terraform script to create infra? The answer is yes. And it's not only Terraform that the orchestrator can execute, it can basically execute any kind of infrastructure as code language. Currently, most of the customers of Humanitec actually use Terraform, which is also pretty prevalent in the industry, but there are also other things out there. And we are catering to that need with a generic IAC driver, which allows you to choose the IAC of your choice and be happy with that. Actually, if you have a broad and rich legacy, or heritage, and you use multiple IAC languages and you always had a problem that they could not really well communicate between each other, well, the orchestrator makes that very easy because each node of the graph can have its own IAC implementation. Cool.
Okay, no more questions then. You can also contact Clemens in Slack, as he mentioned. I don't think we're going to get any more questions.
I can run away. Awesome.
Okay. Thank you so much, everyone, for joining. And thanks so much, Clemens. Okay, we've got one more. Sorry, one last.
Hit me up on Slack for that one, because I know that there is going to be some specifics coming after that. If you say customize to my company's needs, right? Hit me up on Slack. I'll be happy to have that conversation with you. Cool?
Okay.
I don't know if you heard that, but my family is screaming at me. Time's over.
Okay, well, thank you so much, guys. And Clemens in Slack, so ask away. Thanks so much for a great presentation, Clemens.
Thank you very much, Liv. Have a wonderful evening, everyone. Speak to you soon. Bye-bye.
Bye-bye, everyone.